You're listening to China Manufacturing Decoded from the Sofeast Group.
Hello everybody, welcome to the China Manufacturing Decoded podcast. This is episode number 234, and the topic today is ensuring that you get accurate prototypes. And this is sort of a how-to guide on how to get good parts for your prototypes and get good prototypes, let's say as good as they can be, at least based on that design iteration, of course, so that you don't waste time during product development to order the parts again and go and talk to the supplier and sit down with them and show them the problems, etc., etc. It's like production. If you get things done right the first time, you work with the right people and so on and so forth, you're going to get to your objectives much faster, right? I guess it's obvious, but then the question is how to do that. And that's what we're going to cover today. And I'm here with Paul Adams. Hey, how are you doing?
Hi, Renaud. Yeah, good to be back. And 234. I keep on saying it, but these numbers are getting impressive.
Yes, they are. So let's get right into it. First, what are the main types of prototypes, right, during product development? And let's try to keep the answers relatively generic, right? For a company that might develop a new, maybe consumer electronic product, maybe a new mechanical product, maybe a electrical home appliance, right? It kind of all follows the same process, more or less, right? And let's assume that there are some aesthetic requirements. What are the main types of prototypes? Let's say the big categories.
Well, to start with, we've got to break down sort of what the prototype is being used for. So we've got the rough prototype is the first prototype that you're going to be looking at. And this could be, built out of cardboard or styrofoam or something like that, just to give you a rough shape, a concept of what it's going to look like and stuff like this. So, getting that type of prototype accurate, it is not that important because we're not looking for accuracy on any of the parts or the dimensions. We're purely looking for aesthetics with respect to how it looks, the size of it compared to something else, or is it going to fit into a certain environment, etc. And so that's the first style of prototype that we're looking for. After that, we're looking for something a little bit more refined. So that's where we're going to be looking for some dimensional tolerances on parts and components coming in to make sure that everything fits together. Okay, maybe we're going to be doing some initial functional testing, making sure that the product works to the expected specification or functionalities that are put down within the product specification itself. And then the third prototype we're really looking for is something a little bit more robust. This is closer to the production end of the prototype phase, where we're going to be looking at reliability testing, for example, or longevity testing, or any of these other tests that require a more close to production intent style prototype. So let's keep it as those three stages at the moment, or those three types of prototypes.
Might be for compliance also, right?
Correct. Yes, right. Exactly.
Right. So first type of prototype, as you said, made of cardboard or styrofoam or something, that might be completely virtual, right? Just mock-ups by an industrial designer. We're not really talking about that today, but we're talking more about the other types of prototypes that you mentioned. All right. So why is it so important to ensure that, you get the right parts with the right dimensions, the right, surface finish, the right properties, etc., when you're going to put together a prototype? Was it so valuable for a product development team?
Well, initially, we talked about the second style of prototype, which is your functional testing or some of your initial testing. Now, this is really important where we've got mechanical components that are moving or some interface with respect to components fitting together. And it's super important. So let's take a simple gearbox, for example. If we are getting components in that have not been specified, which is, we've got 10 gears, and each gear has got 10 teeth and needs to fit on a shaft of 10 millimeters diameter, and this is broad as that. Well, I'm not sure what you're going to expect. Is it going to fit? Is everything working? Is it going to mesh together correctly? Is the gearbox going to turn? Probably not. So it's really important to understand that on a prototype where we're looking for functionality, we need to understand what those functional parts are within the sub-assemblies itself, and making sure that the system works as a one sub-assembly system functionality, and then as a system together. So all of these sub-assemblies could actually fit together and make one big assembly. Everything needs to function. And in order to function, in other words, rotate or fit together correctly, snap fit, unsnap fit, we need some accurate prototypes to be produced.
Right. And all of that makes me think there's a lot of parallels with manufacturing, right? You also need to take care about all these things when you industrialize a product, just to make sure you're going to get consistently what you need. But the thing is, a lot of product development teams, a lot of R&D teams are not in that mindset, right? And they kind of just say, okay, let's get things going. And they tend to be a bit more on the optimistic side, maybe, not really always thinking, okay, what could go wrong? What could I prevent, etc. It's more like, let's get things done. Let's see how fast we can get there, right? And sometimes they kind of skip a few steps, but then the result is that they might be wasting a lot of time in the entire project because of extra iterations in the prototyping loops. Okay, so basically, coming to the sort of the beef of this podcast episode, right? What should these product development teams keep in mind? What are some good tips for them to follow? What are some good practices? And Paul, you wrote an article, came out last week on the Agilian blog, and it's full of very good advice. So, do you want to run us by these tips that you suggested?
Yeah, I won't repeat myself, but that's a good read. So let's cover that in more of a helicopter view. But yeah, you're right. It's really important to understand horses for courses here. Yeah, if we're looking for something that is functional, it needs to be relatively accurate and representative of a pre-production unit, then there are certain steps that we must follow in order to achieve what we're setting out for. In other words, something that works and we can test against a specification. So the first step, really, that is something I wrote here in the blog, is really producing enough information such that the supplier understands what they should be delivering. Okay, and this is not just a set of drawings, and it's not just a set of dimensions on a drawing, even though that is really important. They need to understand what the functionality of the product is 9 times out of 10. There are some occasions where they don't need to know, but in general, let's say it's important for them to understand that, this product's going to be used in this environment or under this stress, or it cannot be allowed to degrade under certain conditions. Okay, so it's important that the supplier understands the functional requirements, because they may be very knowledgeable in the material or the process that they are providing, and may be able to offer some very valuable advice. The other one is assembly conditions, is something I wrote in the blog as well. And again, it's, how accurate does everything need to be? Because the more accurate things need to be, the clearer the information needs to be from a dimensional point of view. We may need to add geometric tolerances and surface finishes, and all of this adds potentially to the increased cost of a single prototype. So this is really important as well. And the assembly conditions really matter in some of the functional testing that may be required in your product, for example. And that really leads down to the next thing is material selection. Now, I had the conversation with a customer this morning with respect to production needs to be a certain material, but for a prototype for testing, certain components can deviate from the production intent material just to get the prototypes up and running, because certain areas were deemed, well, that's less important now, but for production, it needs to be XYZ. So again, it's really important to understand the requirements of the prototype, talk to the supplier, get their understanding of their materials, what they have, what their capabilities are, and what advice they can provide on, specific key and sometimes exotic materials that they can work with and mold. So that's the first thing we're looking at, is getting enough information to the supplier such that they can understand what the requirements that you need that they can supply.
Right. If you don't explain what you want, are you going to get what you want, right? So it's the same logic here. And that's just amazing how often I see design engineers saying, okay, we want this, we want a piece of plastic that's going to do this, or we want a glue, but without saying what exactly you're going to glue together, right? You don't give sufficient context to the supplier, so the supplier doesn't know. And sometimes I remember some troubleshooting, some kind of AD problem resolution exercises where we look into a big problem to really understand why it happened, and we go and talk to the supplier of the critical material or component, and then we explain what happened, and they're like, "Oh, what? You use this to do that? I mean, what? You never told us about these kind of things, right?"
Yep.
And it's the same. It's the same during product development. If you don't explain, first you need to provide some context, and also you need to work with the supplier maybe to determine exactly, okay, how are we going to measure that? How are we going to test that? It's your interest because you want to make sure, you can tell the supplier, hey, this is bad based on what we discussed. It's also good for the supplier because if they know exactly, then they can check on their own and, okay, maybe no, not like this. Okay, machine it a little bit longer here or whatever, use a different configuration. Okay, now we get to what they want. It's also good for them to know, right? So very, very important point, right, for R&D teams.
It is, and another key thing, so particularly here in China where we are, is it's never make the assumption that the supplier understands what you're saying. Because if you don't specify something, they will guess on what you require. And more times than not, they're going to guess wrong. So it's really important that you actually supply exactly what you need. Okay, which really comes down to the next point I want to discuss, which is it's all about communication, and that follows on carefully and swiftly to supplier capabilities. So communication is key. You have to build up a good relationship with the supplier, and it's really important to keep the communication channels open and regular. So having regular, consistent meetings, and even visit the factory or the supplier to check up on progress, make sure everything's going to plan. You can always do in-process inspection halfway through to make sure that everything's on track with respect to what you're expecting to be delivered. And if there's any issues there, obviously we can catch them as early as possible. So that's key, to keep communication open and consistent and frequent. But when it comes to capabilities, I see this issue time and time again, and I have done, is that there's a tendency to go back to the same supplier because you've had good results from one batch or two batches of products. So everything, assuming, is going to be the same. Therefore, we're going to use you again, Mr. Supplier. Well, that's not necessarily the case when you're changing or when you have a very specific product that you need producing. That may be out of their capability range, or they may not be able to offer the same quality as an expert in that particular area. So we've got to look at the capabilities, their machine capabilities, their quality control capabilities, and we've got to look at the expertise within the team itself with the supplier. Now, some suppliers absolutely incredible, and they can offer you anything. They claim that, don't worry, whatever you've got, we can do it. Well, I would rather go with, if you've got something specific that you can offer, then I will offer you that particular job to produce, and I will find somebody else to produce something very, very specific that requires different set of skills or capabilities. Okay, so that, again, it's really important. We're matching requirements versus capabilities of the sort of supplier.
Yeah, definitely. Work with the wrong people, get the wrong result.
Absolutely. Time and time again, we're seeing that.
Yeah, again, it sounds very basic and very, very easy to understand, but not everybody acts on that, basically, right?
Yes, that's right. We had one particular case where we were making a product. The supplier claimed that they could meet various different tolerances with a process. The questions were raised because we didn't actually believe the information that was coming from the supplier when the parts came in. Sure enough, nothing fitted together. So it's really a case of like pushing back and really understanding the capabilities of the supplier and not just taking the face value, as it were, of what they can claim.
Right, definitely, yeah.
So the next thing really is all about delivery. So assuming that you've actually kept the communication open, you've provided the sort of specific requirements for a product or the products you're actually producing with that particular supplier for your prototype, the next thing is making sure that you are going to get what you want when they say they're going to deliver. So there's a couple of things now. When they say they're going to deliver is all about deadlines. So it's important to actually understand that they can actually achieve certain deadlines and keep to that schedule, which is really good. And this is, going back to what I was saying earlier about communication. It's important to keep the lines of communication open and frequent. And timelines and deadlines is a key important thing or a topic to discuss, as well as any technical issues that they may come across. So that's one thing there. But then it's really important that they don't just send out products without any other information. One of the things that I'm pushing back on all of our suppliers at the moment for prototype parts is they need to provide an inspection report. They need to provide video evidence of surface finish or something like this, or sort of photographs of close-up key areas or critical components need certain features. What I'm looking for before they send me any product is evidence that they've produced the part to specification. So that's video evidence, photographic evidence, and an inspection report. Those three things should not be out of the ordinary. So make sure you ask for them when you are talking to your supplier.
Yeah, definitely. So a lot of communication and, let's say, structured communication, right?
Yes,
This
yes.
needs to be planned and done in a certain way, let's say.
Yeah, definitely. So assuming that your supplier has sent through sort of the photographs, you've had a video call with them, they've showed them around the process, or what do you ask for specifically to be shown? You've got the inspection report, everything looks good, they should send you the products. Okay. Now, the next thing, the obvious thing, but not necessarily followed thing, is for goods inwards or incoming quality control. Every part that comes into the company should go through incoming quality control just to make sure that dimensions meet the required specifications on the drawings that you supplied to start with. Now, some of that information can be in a CAD file. Other information is going to be on the 2D drawings that you supplied. But nevertheless, everything should come through IQC as a process, whether it's going to be a one-off or a small batch of 10 or 15 for your prototype build. Everything should be inspected as it comes in and not released until IQC have gone through their process of checks and produced that report.
Well, that's if you're operating a manufacturing facility like us, then if you have an incoming QC team and they have all the necessary measuring and testing tools, etc. Okay, that's a way that makes sense. If it's just a few mechanical engineers in an office getting things, well, they are going to be the ones actually checking the parts that they receive, so that if there's an issue, can be sent back, or the feedback can be sent to the supplier, and maybe some parts need to be remade, right? So don't wait until you have everything and then start to build the prototype and say, this doesn't fit well with this or whatever, right? Ideally, you already know your critical to quality dimension points. You know how you're going to measure them, and you check that early as you get the parts, right? So if there's an issue, you can work on getting a replacement, okay? And that's how you get closer to getting, good quality parts the first time again, which is extremely important if you want to keep your product development iterations to be much shorter.
Yeah, exactly. It's also, of course, it's really on the size of the department you're working with. Like I say, we've got our own department for IQC and everything like this, but if it's just a smaller organization, it's really important to get that measurements done before you actually get super excited. Now, don't get me wrong. When you get your parts in for your first prototype, it's a very exciting time. And the first thing you want to do is build, and put this thing together. But patience is a virtue, and we really need to go through that process of making sure that everything is correct before it's put together. And this is also going to show when you've got a supplier you've been working with, if you followed the process or even the steps that we've just been talking about or we wrote about in the blog, is everything should be okay. But, if you're intending to use the supplier for the prototypes and then switch that up, in other words, sort of scale with that particular supplier into production, if you're getting errors on small batches, then this is a bit of a red flag or a warning particular with respect to, hold on, if they can't produce under very tight control 2 or 3 or 10 or a very small batch, what are they going to be like on mass production? So again, this is something to consider with your suppliers, and it's really all about matching the supplier capability with your expectation and specifications for the products and each component that builds that product up. So, which is good. Now, we talked about self-inspection or getting IQC to actually look at these parts. Now, what do you do if we get parts in that are coming in incorrect or wrong or out of specification or the wrong color or scratches or whatever the case may be? Now, it's very easy to say, okay, I'll just push that back. Or Renaud said, if it's not right, let's go back to the supplier and correctly so get them to rework or correct the parts or actually remake them and resend in. But it's really important to understand what the issue is. In other words, we really should be looking at a root cause analysis. Now, if on the surface everything looks okay, when I talk about the surface, you've done your dimensional checks on one component, everything seems okay there. You've done your dimensional checks now on the second component, everything is okay there. The third component, same again. But when you come to assemble it, it doesn't assemble correctly. There's something else wrong. So we really need to understand what the root cause is and why that is not functioning correctly. When it comes to electronics, we had a recent case where everything seems to be okay. It's all very good. The IC was the issue. And when we looked at it, we had to do the X-ray inspection, and there was a bridged solder gap on two of the BGA points that obviously caused a bridge. Therefore, the IC didn't work. So you need to understand what the root cause is. Now, the root cause is not the bridge itself. It had to go back to the solder paste process of the bare PCB, and that is where we saw the problem on the mesh that's on the screen where we was putting down the solder paste. That was the issue, that it was slightly broken. So it's really important to actually go back and have a look at the root cause of any issue that you find during this initial inspection, because understanding what that root cause is will allow you to put in a corrective action. That corrective action could well save your bacon when it comes to mass production. Okay, so it's really important that you follow the steps and understand each of the issues. If you've got any issues come through that are allowing you to, or sort of stopping you from moving forward from building this functional prototype. Now, I'll go back to the original, very first thing we talked about, the 3 stages of the prototypes, bearing in mind that we are now talking about functional prototypes, and it's really important that we get the functional prototypes functioning correctly such that we can analyze the product, we can tick off the boxes with respect to the specification before we move into more robust prototypes and design changes before we go into production. Any issues found here that are not addressed will find themselves in production. And the last thing you want to be doing is doing a product recall, which is very expensive. It brings on all sorts of problems from a reputation point of view, from a supply chain point of view, from a wasted money point of view, and the list goes on and on. So it's important to understand where we are, understand what the issues are, correct them early in this prototype stage before we move into, even before the next prototype stage, which is really all about long-term testing, reliability, and certifications.
Absolutely, yeah. So you have caught the issues, if any. You're managing these issues. Okay, are we getting close to actually building the prototype? Where are we in all of your good practices, let's say?
Yeah, and good practice, that's a good way to put it. So basically what we're doing is follow these steps, and we've got all the information over to the supplier. We've got the information back. We've got the parts back. We've done the inspection. We've potentially found some root causes. We've got the corrective actions in for the next build. We've got everything replaced. So we've now either, in our case, IQC have released the parts. They've come down to R&D. Or in some cases, we've inspected ourselves, we've recorded everything down, we've documented each component, dimensions, and everything like this, and everything's good. Once everything is ticked off, okay, we've got all the components on the bill of material, we're now ready to build, we're all good. So that is basically the next step of how to get your prototypes up and running in the first pass, let's say, without going through multiple iterations of this part's not correct, can you replace it, all the rest of it. So once you've got your parts, you're down into the R&D lab or you're on your workbench, and the next thing is to actually build the prototype. Now, obviously, each component goes together correctly with respect to whatever product you're building or whatever you've designed, and there's a process that should be followed. And I think this is the next step that needs to be documented very carefully with respect to design for assembly or design for manufacturing. And this step can really help move forward into pre-production stage of any new product development. And this is really looking at the product design and working out which components need to be fitted or assembled first and in which order. And that should be documented down. All this needs to be recorded, and that can be then translated into work instructions and any areas of concern that needs to be specially looked at from an assembly point of view. So, assuming that everything's come together nicely, we are looking at the final approval of a prototype that has taken very careful consideration of all of the best practice that we've just been talking about. You shouldn't have to go through multiple iterations of getting components in that don't work, don't fit, wrong material, there's rusting, there's falling apart, there's bending, and then all of these wrong issues. Everything should have been taken care of if you followed these best practices. Now, like I said, we wrote a blog post. I wrote a blog post that's on the website, Agilian website. Follow these best practices in order to get your prototypes up and running as quickly as possible. Okay. And it's important, once you've got everything built and tested, running, provide some feedback to your supplier. If they've done a good job, tell them. And this is all about, what we talked about in the middle of this podcast is, building up the good supplier relationship. And that doesn't just start at the beginning. It's a continuous relationship building exercise. So if someone's done a good job, tell them they've done a good job. Okay. And this is very, very helpful, particularly here in China. It's a thing. It's a cultural thing that goes a long way.
Oh yeah.
So
it helps a lot.
It's definitely, yes, it does. It definitely helps. So once we've got the prototypes up and running, that's basically it. You need to document everything down from a work instructions point of view to, move into the next pre-production stage, and everything's good. So I'm hoping that's sort of enlightened you for best practices on looking at all of the steps to get your prototypes in as accurately as possible.
Yeah, I think this is very, very practical advice, and a lot of that carries over also for getting samples that look nice, right? For cases where the surface finish, the color, needs to be matching the very nice renderings of the industrial designer, right? A lot of the same things. So you talked a lot about dimensional control, but really there's a lot of other things also, and it's the same good practices. It's the same things, right? And a lot of that will help you make the product better, because as you understand when getting parts for prototypes, okay, you understand the limitations of the processes, you see which supplier is doing a good job here, a bad job there, is, maybe has better service, has more, has the ability to do more. Okay, some of that translates also into what they can do for mass production. And if you know how to measure and test and so on, well, this will go directly into the incoming quality control plan and documents for mass production, right? Now,
exactly.
Just one big caveat, obviously, is that it's not exactly parallel. You can't just keep doing the same thing. What we see is that some suppliers are actually quite good at making 1, 2, 3, or 10, parts or prototypes. But then when you start to go into, hey, let's make 500, let's make 2,000, then you start to see a lot of inconsistency. Some people are good at setting things up, but they're really bad at managing their processes to have a consistent output over a series of hundreds of thousands of tens of thousands of parts, right? So it's not all exactly parallel, but a lot of the same advice would apply to mass production. So yeah, thanks a lot, Paul. That's been great. Again, I think very useful.
Okay, yeah, pleasure.
Very useful.
Look forward to the next one.
Yeah, so do we. So thanks to the readers for following us, and you will hear from us next week as usual. Thank you, and till next time.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.